All right, guys, then we're going to solve exponential equations, equations with exponents in them, where the actual what you're trying to solve for, where your x is actually in the exponent. So here we go. One property you need to know, and that is the base exponent property, which basically says this, and it should be kind of common sense when you really think about it. If a to the x equals a to the y, I mean, are you kidding me? If the a's are equal, that means your exponents must be equal. Like a cubed would equal a cubed. A cubed would never equal a squared or a to anything else. So if your bases are the same, the exponents must be the same if they're equal. And we're going to use this property on the next slide. Here we go. This says 2. The first one says finding the same base. Now, if you notice, now part A right here, the bases are different. I have a 2 on one side, 32 on the other. What I need to do is make them both the same. So I'm going to have 2 to the 3x minus 7. And over here, I'm going to write 32 as a 2. And I happen to know that 32 is 2 to the 5th power. If you're not sure, you can use your calculator and keep punching 2 to the 3rd, to the 4th, until you figure out what it is. Now, because the bases are the same, they're already equal, that means my exponents must be equal. So I'm going to forget about the 2's, just set my exponents equal to each other, move the 7 over, divide by 3, x is 4, and that's all you gotta do to solve it. So the key there is finding the same base. Let's do one more. This second one, 81, just happens to be 3 to the 4th power. Once you have the bases equal, you don't have to worry about the bases anymore. Just set the exponents equal to each other, divide by the 4, x is 1, and there you go. And you can, by the way, you can plug those back in, to your left-hand side, and you'll find out that they work. They do solve the equation. So, next one. All right, what if you can't find the same base? Good question. If you cannot find the same base, that's where logs come in very handy. So what I'm going to do is I'm going to do log of both sides. So on part A, I would do log 3 to the x power equals log 20. I'm not putting a base because I'm doing base 10, because that's what my calculator knows. So don't forget your rules. This has an exponent. The x is the exponent. It goes in front. That's why this works so well. X log 3 equals log 20. Divide both sides by log 3. You get log 20 over log 3. And all I'm going to do is I'm going to take my calculator and punch that straight in. Punching in log 20. Make sure you close your parentheses. Divided by log 3. And you get 2.7268. And there you go. So when you can't find the same base, you can't break 3 and 20 down into the same base. So you got to do log both sides. Same thing on the next one. I'm going to change colors here. Same deal. I'm going to do log of both sides because I can't find the same base. And don't forget the exponent goes in the front. So I'm going to go ahead and put the exponent in the front. X plus 3 log 4 equals negative x log 3. All right, now this one's a little tougher because you got x's everywhere. So what I'm going to do is I'm going to go ahead and distribute this left-hand side, make it x log 4 plus 3 log 4 equals negative x log 3. So all I did is I took this log 4 right here and just distributed it through that parentheses. Now, I need to get my x's together. So what I'm going to do is I'm going to actually trade places with those two logs. Okay, so I'm going to make it x log 4 plus x log 3 equals 3 log 4. And I still don't have the x isolated. I've got to find a way to get the x out of those two logs. So I'm just going to factor it out. It's the GCF. So I'm going to factor out the x, which leaves me log 4 plus log 3 equals 3 log 4. And to get my final answer, what I'm going to do is, I'm going to move this just a little bit. I'm going to divide both sides by that. So it's going to look like this, 3 log 4 over log 4 plus log 3. And what I'm going to do is I'm going to punch that straight in my calculator, just like I see it. You got to be very careful when you punch this because I have two things on the bottom of the denominator. So I got to put that all in parentheses, punch that in, and I get negative 1.6737. All right, for my final answer there. That's a pretty good problem right there. I'm going to look at that one more time. Make sure you're good with that. Got a couple more slides here. All right, I wanted to show you one that has an E in it because it's going to work just a tad bit differently, but really not. It's really easier, to be honest with you. So here's what we're going to do with this one. First thing, I'm going to isolate the E. So I'm going to divide both sides by 1,000. So I get this right here. 5,000 divided by 1,000 is 5. Now, because I have an E, all right, I'm not going to use LOG. I'm going to use LN both sides. Because what happens when I do my natural log with an E, what happens is, that, remember, the exponent goes in the front And natural log and e, that's really e to a power z, they're really gone. So all that leaves me on this side right here is 0.09t. And over here I have natural log 5. So my final answer is going to come from whatever natural log 5 is divided by 0.09. So when I punch that one in, when I punch in that into my calculator right there, let me see what I get. I get natural log 5 divided by 0.09, and I'm getting 17.8826. Notice I'm going 4 decimal places pretty much all the time. Most books and text, when you're doing log problems, they want you to go 4 decimal places. That's kind of where we're going today. Hope that made some sense. The hardest step, it's not hard, but the main thing is you understand is how we get from there to there. After I do natural log both sides, the answer to a natural log e, we did this the other day, like, is just the exponent. Whatever the exponent is, that's how you do it. Natural log and e, they don't cancel, but they do. But they don't cancel. So anyway, one more. My last one here, e to the x plus e to the negative x minus 6 is 0. Now here's what we know. E to the negative x flips the e like this. Right, so what I'm going to do is I don't like fractions when I start to work, so I'm going to multiply the whole equation by e to the x and get rid of that fraction. So what happens first, my first term becomes e to the 2x, because when you multiply e to the x times e to the x, you add exponents. My second term just becomes a 1, the e to the x's would cancel, and I'll get negative 6 e to the x equals 0. What I'm going to do now is rearrange it to where my exponents are in decreasing order, like we always do here, plus 1. All right, now, what I'm going to do, because I'm not used to factoring or working with e to the x, is I'm going to do like we did earlier and let my u be e to the x. So if I substitute u, I have u squared minus 6u plus 1. And good and bad here. The good is it's not a very hard problem. The bad is it doesn't factor. There are no factors of 1 that give me 6. So what I'm going to do is I'm going to complete the square, because this is an even number in the middle. So if I take half of 6, it'd be negative 3. And if I square negative 3, I get a plus 9. I'm adding that to both sides. So it gives me this. U minus 3 equals 8. U minus 3 squared equals 8. So I'm taking the square root of both sides. So I get u minus 3 is plus or minus 2 on the square root of 2. So u is this. U equals 3 plus or minus 2 on 2, which is good, but that's not what I'm looking for. I'm trying to solve for x. So I'm going to substitute this back in for the u. So I'm going to say e to the x equals 3 plus 2 on 2, and also e to the x equals 3 minus 2 on the square root of 2. All right, to solve that, because it's an e, I'm going to do natural log of both sides. Natural log of both sides. I forgot natural log here, natural log there. So what I've got to do is, remember, when I do natural log of just an e, all I get is the x. You just get the exponents. Over here, I just get the x equals. So what I've got to do is I've got to take my calculator and punch in natural log of 3 plus 2 on 2, and natural log of 3 minus 2 on 2. And when I do that, I get this right here. I get 1.76 and negative 1.76 when I punch that in. All right, so there's that. That's a pretty good one too. We'll work on these in class tomorrow, and we'll be great at the end by the time you leave, I hope. Actually, I know you will. And I'll see you then. See you tomorrow.